Okay, welcome to Wednesday, September 16, our class session. Okay, let's get started. And I've got some useful things to do with you today. And in particular, also showing you how to use your calculator. So let me just keep adding people to the room. So the first thing I wanted to do is give you a chance to ask questions or give me feedback, and you can be pointed but polite about just your first homework handing in experience last night, because I definitely was working with a lot of people, and I've collected what you handed in and I can give you some feedback, but I'll give you graded return papers and grade reports later this week. But is there anything I can clear up about just submitting or doing your homework, either in XYZ or the written homework? And be direct, be polite, but be direct. If you have a problem or if something's not working, let me know. It can't be that everybody had a perfect experience. On the other hand, I realize that some people that had issues that they had to resolve may not be here right now. I'll give you the number one issue I saw, and I did try to send back a polite note after I saw this. Remember, you should name the files you submit. Last name, first name. I don't have room here. Homework 01. MTH 121. And then whatever section you're in. FA 810 or FA 130, 830. And the reason for that is I get a lot of papers and I got to keep them straight. So if I just got crazy photograph names, then I have to be very careful that I know where that belongs, which class it belongs, who it actually belongs to. Second item that I observed. Make sure you send me PDF files. Now, it's okay to snap a casual picture. And in fact, you can snap a picture and then turn it into a PDF file. But this is not sharing on TikTok, so to speak. I mean, you want to present to me your work. So you want to make a nice image, not a dark image, not a tilted image, not a bent image. You want to take a nice picture and then convert it to a PDF. Now, most phone, computer will do that automatically. Okay, Gabe makes a good point. I'll bring that up. But worst case scenario, if you were holding a picture that you took with your phone or some device, you could send that to yourself, open it on your computer, and then just say print as PDF, and your computer will convert it to a PDF file. So that's going to make it easier for me to write on and easier and faster for me to return to you. And then I'll start to address your questions. So good, throw the questions in there or any other questions. Last thing I noticed, just making myself a short list, Write neatly, write darkly, of course, but please write your name on your paper. You know, if some disaster happened and I lost track of what that file name was, or sometimes I got file names like this, BA6CD4972.jpg. There's nothing in that that tells me whose paper that is. So make sure that you write your name on your paper, just like you would in any ordinary situation. Now, when you submit the paper through the assignments folder, through the Dropbox, it is attached to your name, but then I have to remove it from the Dropbox. I have to get them together. And I'm just thinking if some kind of accident happened, I do want your name on your physical paper that you're taking an image of. Okay, so that was 1, 2, 3 that I noticed. Now, I also got questions like this, you know, are you going to grade the paper down if it's not got the right file name? Are you going to grade the paper down if it's not a PDF, et cetera, et cetera, et cetera? No, I'm not going to do that. But over time, let me bring another person in the meeting here. Over time, I want to get everyone to the place where you're submitting it with the right file name and the right PDF format, because that just makes everything move smoother. Last night I spent about 2 hours, because I have more than one class. Spent about 2 hours with a couple classes renaming people's files and converting them to PDF files. And, you know, I just want to gently say to you all, you are producing your work for your instructor. The instructor shouldn't prepare your work for you. Now, that is not a knock. That's just talking about how you're going to work in the real world. You're not going to hand a supervisor a report and the supervisor is going to have to add your name to it and staple it and make sure it's clean. So make sure, think about your homework that way, that you're providing a report to someone. Your product was good. And wait till I grade it and give you back feedback. I mean, not every problem was right. I'm not expecting that. But you did good things. You just have to polish the way you present them and hand them in to me. And then it'll make your things better. It'll literally make your things better. So what else do I want to say to that? Over time, I would say last night about half of the people delivered PDF files and half delivered images. I would say about half of the people delivered me the file name the way we specified in the syllabus, and half of the people got some crazy file names or some different file names. So that's pretty good for a first attempt in my book, because I've seen things like this happen over and over again. So let's just make this your target, that you got the right file name, you have the PDF file, and you actually write your name on your paper. Now let's check the comments, and you can throw any other comments in there too, because you've made some good comments here. Austin points out that you can copy and paste a picture into a Word document, and you can fill up the paper and then convert that Word document into a PDF file. Absolutely. The number one way to create a PDF file out of anything is just to open it on your computer and print it or send it to the printer. And one of the options when you send it to the printer is to print as PDF. But inside programs like Word and such, there's probably even choices that say convert this to a PDF. So PDF is kind of the standard for trading documents. Gabe talks about issue with XYZ homework doing some problems. Absolutely. Oh, Shakira points out my number one way, and I'll come back to that. But Gabe points out that, just issues with the XYZ homework, learning how to do some of the problems, videos didn't always help, limited examples in the book. Absolutely 100% right. And it's going to take a lot of reading and doing to do those problems. But let me give you 2 tips. Every problem you see in the homework is going to be like, it's not going to be an exact copy of the book. Shakira, okay, thank you. That's kind of funny, because not funny, my mispronouncing, but funny because on the first day of the class, if I was in a regular class, I would read the names and I would tell everybody, tell me exactly how to pronounce your name, and then I would write kind of phonetically like you just did on my attendance sheet exactly how I should pronounce it. You're obviously going to say, everybody's obviously going to, well, you could do that here too. And I could, but I didn't even think about that. So thanks for pointing that out. Okay, back to the homework on XYZ. Notice that the homework on XYZ is not going to be an exact copy of what you read in the book or see in the examples, because they want to see if you've extended to learning something. Sometimes it is exactly stated the same way. And they cannot give a video for every single problem, but they give good videos. And that's part of the reason I'm here. I can add some videos. I can add some explanations. I can add some written examples for you and the recommended problems. But that's what I'm going to throw on you. You may not be able to find a perfect match for the problem you're trying to do in the book, but you find the best match you can. And then I can give you examples of how to do things like that, even here in class. Some of you are typing questions into the homework system forum. So in other words, you could ask questions right there in the homework system. And I do get around to answering those, and I'm keeping a handle on them, within 24 hours. But I'll tell you one thing that didn't work, and it doesn't work for me when I'm behind schedule. Last night, my emails from all my classes went to 2 or 3 per day to about 50 between 10 p.m. and midnight. And that's okay because I'm used to it. Except I'm not going to give you very good service when you're one of 50 people between 10 p.m. and midnight. The demand and the deadline's at midnight. I will give you the best service I can. But make sure you're doing a little bit of this every day so you can get your questions answered first. I'm not suggesting be selfish, but be selfish. Get your question answered before the other people's questions by working on it every day and bringing your questions every day. So even right now, I realize it's very hard to get in the habit of working on anything every day. It's more likely to get into habits like that when I'm doing something every day, like going to that classroom and seeing that person. And I don't go someplace and see some people very often. Yeah, I get in the habit of not engaging in something. So make sure you're engaging in the problems every day. Homework problems online every day, recommended problems on the website every day. Okay, now I'm going to go back to Shakira's suggestion that I put into the syllabus. In the notes program on an iPhone, or if you use Apple Scan program application on an Android phone or Apple iPhone, when you snap a picture of something in the notes program or in Adobe Scan or Acrobat Scan, that I have the programs listed in our syllabus, it automatically makes it a PDF. So if you're using a phone that you can put one of those 2 apps on, that makes it very, very easy. You're not even thinking about it. You don't have to convert anything. It's just a PDF. And sometimes when I put answers up on a website as PDFs, it's just because I wrote it on a piece of paper and snapped a picture of it with my phone. So that's very, very efficient. We also have a questions folder on our website. So if you're trying to write something on your paper one day and you're not sure what's going wrong, you could snap a picture on the phone, PDF, drop it in our questions folder, because I monitor our questions folders. Okay, so far so good. Remember, I will look at that. Yes, thank you. That's a good suggestion, Jeffrey. Now, but I want to check you on one thing, because I can go and look this up. Try not to say question 2 on last XYZ homework. Find me the example in the book that looks like that. And I'll go and find it right now. But I want you to get in the habit of going back to the book. Even if you're using the book electronically, the book is where the explanations are. The XYZ homework offers you some explanations and access to some things and some hints, but you will not learn anything unless you open the book, either electronically or physically. So let's go find question 2 from 1.5 in the book. Okay, anyway, so more getting used to everything, but it's time well spent. I'll go back to my website for one tiny thing today. And that is, now that you've submitted the first homework problem, notice under homework on the website where I have homework 1 and homework 2, and now you're working on homework 2 and sections 2.1 through 2.3. Homework 1 has a solution posted. So as soon as the deadline passes, more or less, as fast as I can get to it, I post a solution to the problem. And so after I grade your paper and return it to you, you could look at the comments I made, and you can look at the solution I posted. And that way you could say, okay, that's one way I could have done it. That's how I did it. That's how David did it. So I'm not saying this is best or better than anyone else's, but this is how I looked at that problem. So always after you submit, you can look at the solution. You can collect these solutions for studying purposes, yes. And when you get your paper back, you can compare it to what I wrote here, if you like it better or less or something like that. Okay, back to XYZ homework. So Jeffrey's question is good. I want to hit it by showing you where you're going to find that. So Jeffrey's question, XYZ homework. I'm going to log in. Too many logins nowadays, right? And I will see things slightly differently than you see them. Notice sections 1 through 1.5 are grayed out because they're now past due, but they are available here for you to continue working on and studying. You can continue to use them. So if I went into 1.5, we all get different questions, different kinds of questions, but I can see a question like it right here. So write this in terms of cosine only if the answer needs a plus or minus. This is an example from 1.5. Let me see if I can find a book example where it's something like that. Cosine only expression review if possible. Okay, I'm looking in 1.5. Add, subtract, leave your examples in terms of sine and cosine. And I've got this problem right there. That's a good one. And he mentioned how to do that right here. So let me show you. So right now you're looking at the XYZ homework. So I wanted to go and find a problem like it. I look in 1.5 and I'll switch to my camera now. Example 1 in section 1.5 is exactly like this. Let me go back to my camera. Write tangent in terms of sine. And the homework problem said write tangent in terms of cosine. Okay, so I'm not going to write this down. I'm just going to work out this example with you right here. Write tangent in terms of sine. Well, you know the tangent is sine over cosine. So can you express cosine in terms of sine? You know that cosine squared theta plus sine squared theta is 1. So that means if you use this Pythagorean identity, solve for cosine, subtract sine squared, take the square root of both sides, acknowledging the plus or minus, then I could replace that cosine with square root of 1 minus sine squared, plus or minus. And now I've written tangent in terms of only sine, but I have to notice that the plus or minus is here, and I'll have to choose plus or minus based on whether the angle is in one quadrant or another. Let me go back to the homework system because I had some questions on this problem, like this problem, and asking me about the plus minus. So if I'm going to write the answer in here, I'll check it in front of you. Write the following answer in terms of cosine. If it needs a plus minus, don't list both functions, just answer this. So in terms of cosine, if I would repeated that thing in terms of cosine, I would say square root of 1 minus cosine x, and I'll in the square root, and that gets rid of that syntax error, and I misspelled square root. Let's try again. There we go. And I better square cosine. Notice the answer is trying to help me tell me what I wrote next to it. Okay, so this is what I wrote. They say error unbalanced parentheses. I must have too many parentheses on this side. Okay, I got rid of it. Now I'm going to divide that by cosine x. And I'm going to decide, do I need a plus or minus? So the cosine x is going to be positive or negative. The square root is always going to be positive. When cosine is negative, tangent is negative. When cosine is positive, tangent is positive. This is always positive. So my understanding, I can only try it, is that I don't need to write plus or minus on this. So when the book asks me, is there a plus or minus? I'm going to say no. Now let's see what happens. I'll submit. Now, this is something I have that you don't have. On the instructor side, I have that the book will show me the answer. But let's just submit just so I can see what the machine responds to me. The machine responds that it wants a plus minus there. So I'm going to have to rethink that. And I was pretty comfortable that the plus minus shouldn't be there. And so I did get a couple questions about the plus minus issue from some of you. I'll have to review that and see if the book is answering that correctly. Oh, and here's another thing I have that you don't have. On my side, if I see a problem that I don't like or that I think has got a bad answer, I can alert the publisher. Maybe you have that too. And don't be shy of telling me if you think a problem's got a bad answer. Just send me to it. Tell me the section and the question, though, please. I got a lot of screenshots of just a little portion of a screen and saying this question is not working. I could puzzle out where the question came from. But please tell me the section and question number. I'll find it a lot faster. Okay, so do I really need a plus minus there? I am nervous. I would feel very strongly that I don't need a plus minus there. And I'll show you why. Let's think about, and then I could be wrong. See, someone gives you an elaborate, beautiful explanation, it could still be wrong. So let me switch back to my paper. And I've got this angle X. Maybe the angle X is right there. And then I've got the tangent of X, which is defined to be, using X for angle and X for side length is kind of destructive, isn't it? But if I have a point here called AB, then the tangent is B over A, which turns out to be the same thing as B over R over A over R, which turns out to be the same thing as sine theta over cosine theta. And then I replace the sine theta with square root of 1 minus cosine squared theta divided by cosine theta. And now you see my prejudice. Whenever I name an angle, I like to call it theta. I'm not used to naming angles X. I saw that, and I did get some questions on that. So let's write it the way they wanted us to write it. 1 minus cosine squared X. You got to be flexible with the variable names, cosine X. Now, here's the question, and here's why the plus or minus should be considered. First of all, square root of something is never negative. But tangent can be positive or negative, depending on whether the A and the B are positive or negative. So I'm thinking to myself, when is the tangent negative? When one of these people is negative. Tangent is negative if you're over here. If this is the angle X, and this is the point AB. But for that red angle that I just drew, sure, the tangent will be negative, but so will the cosine. So this cosine is automatically positive or negative. And in fact, when the cosine is negative, the tangent is negative here. But see, now I just talked myself out of my answer. Now I realize why they want a negative, plus or minus. Here, the cosine is also negative. If this was my angle X, the cosine is negative, but the tangent is positive. So I was about to say, I don't need a plus minus because when the cosine's negative, the tangent's negative. And when the cosine's positive, the tangent's positive. But that's not true. Here, the cosine is negative in this green angle, but the tangent is not negative. The tangent is positive. Both A and B are negative. When I take the ratio, it's positive. So that means that I do need to adjust the sign of this based on where the angle is. I'm going to go back to the homework system. And I don't put the plus minus in there because actually they're telling me that part was right. I'm going to put the plus minus in there. Now I'll submit again. And remember, I'm past due. I'm in review mode anyway. So I'm submitting here. Then it says, yes, that's the correct answer. Okay, so how was I supposed to know about that plus minus? I had to think about it. I had to actually draw the pictures. And even my first impression, maybe my first impression could be wrong. And I have to be really careful when I answer those questions too. So I like it. Thank you, Jeffrey. That's a good example. But I am going to challenge everyone with this. I'm getting a lot of questions. What about number 5 on XYZ homework? What about number 6 on XYZ homework? I really want to leave that homework to you because it's your homework. So try going back to the book and finding me an example or problem in the book like the one you're doing, as we did here. This was not a specific homework problem in the book, but it was an example in the book. So sometimes when you're sending me questions, I shoot back to you, very good, see example 7 in section 2.1. You know, I just send you to the example that you should be looking at to answer your question. Okay. Even though that took a few minutes, that's actually kind of productive. So just helping everybody get on the same page again. Let me write this down. Got it. Okay, so let's move on to something else today. Actually something, you know, very practical and you can get into using your calculator. Let me write down that this example is like XYZ homework 1.5 question 2. Just in case somebody wants to know later why we were doing that. Okay, I made a drawing for you that I think is going to help you organize things as we're talking today. So let's look at this drawing. Slide it onto the paper. Slide it onto the desk, excuse me. So how have we thought about sine, cosine, tangent, secant, cosecant, tangent so far? And then here's what we're calling right triangle trigonometry. In the book, he calls this definition 2, and he calls this definition 1. In other words, you could do the trig functions by talking about a point on the terminal side of an angle, or you could do the trig functions by talking about a physical right triangle. And that's why people call this right triangle trigonometry. We're going to see a definition 3 in a few days. Okay. I want you to see that sine, cosine, tangent, secant, cosecant, cotangent, they are all the same whether you look at it this way or this way. I mean, you could literally think that I have a tiny invisible right triangle right here. And that the opposite side is y. And that the adjacent side is x. So when I say sine is y over r in this drawing, it is the same as saying sine is opposite over hypotenuse in this drawing. Now you want to be flexible and you want to be used to naming things both ways. So some people say sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Sometimes people remember it and learn it this way, and then later they learn it with x, y, and r. You want both. You want to know both equally well. Okay, let me point out something else in this drawing. So people always abbreviate opposite, hypotenuse, and adjacent to like op, hype, adjace, adj, whatever, but they just say adjacent. Here's second difference in these drawings, tiny difference. When you draw a right triangle, you frequently name the angles with capital letters. And so you could ask someone could ask you, what is the sine of A? And they don't mean the point A, they mean the angle that's at A, the angle that's at the point A, or which is the angle theta here. So sometimes people use a capital letter for the angle instead of the Greek letter theta. So be flexible for that. But I want you to think about what these definitions mean in terms of these two questions now. And I'll see if I can get this all on one screen. Kind of, yes, good. So what would it mean if the sine of theta was really close to 1? In either picture, let's say the sine of theta is very close to 1, like 0.95. If the ratio of y to r is close to 1, what does it mean that y and r are about the same length, or nearly the same length? When are y and r nearly the same length? Well, I guess when I'm looking at an angle that's nearly vertical. So if sine is close to 1, that means that's nearly 90-degree angle. Same thing for cosine, except let's look at this picture. Cosine is adjacent over hypotenuse. This side, the adjacent side to A, divided by the hypotenuse. Now, it means it's in reference to this angle A. So if adjacent over hypotenuse for the angle A is nearly 1, it means the adjacent side and the hypotenuse, again, are nearly the same size. When would that happen? Well, if the angle is very small. You know, a tiny, thin triangle. I'm drawing too small there. A flat triangle, a short triangle, whichever way you want to say it. So that angle is nearly 0. Or it could be over here. Short, and on the other side, that angle is nearly 180. And you could say the same thing if sine or cosine is nearly -1. How about if tangent is nearly 1? Well, tangent is opposite over adjacent. Opposite side to A over adjacent side to A. That's the tangent of A. So if that ratio is nearly 1, then these two sides are nearly the same. And when does that happen? That would be kind of when your angle is near 45, 45, 90. Now, likewise, you could reverse everything I just said. If I change everything I just said, if I said sine was close to 0, if sine is close to 0, then now you're looking at this picture where the y is small compared to the r. Well, if sine is close to 0, then the angle is close to 0. If the cosine is close to 0, cosine is adjacent over hypotenuse for A. So if the cosine is nearly 0 for the angle A, then this numerator is very small compared to the hypotenuse. That means it's tall and thin. The angle might be near 90 degrees. What if the tangent is very close to 0? Then this side divided by this side for tan A is nearly 0. That means this opposite side is very short, nearly 0 itself. You could say the angle is nearly 0. Now, I'm just estimating here. I'm not speaking long-term general truth. Just about equal to. I can't tell you what exactly equal to. Here's another important question. Can the sine or cosine ever be more than 1? This is a famous thing that sometimes people get caught up on. Remember, if the sine is y over r in this picture, notice the radius is longer than both legs of a right triangle. The radius is always bigger than y in size. So if the radius is bigger than y, if the denominator is bigger, this is always less than or equal to 1. Even if the sign was negative number, maybe down here in the fourth quadrant. So this y right here is negative number. Here's positive number. R is always positive, and R is always bigger. In that case, then the sign theta would have to be more than -1. So this is a famous thing that you ought to pay attention to. The sine and the cosine of any angle is always between -1 and 1. It's never 1.6. It's never 2. So when someone writes on their paper someday, sine of theta is 2.7, then I'm going to immediately circle that and cross it out. It's impossible for the sine to be 2.7. Sine can never be bigger than 1. Okay, keep that in mind as a safety check. Okay, next drawing, and then we'll do some physical problems. Here's a blow up of a right triangle. I wanted a little larger one so I could draw on it. And I wanted to remind you of the power of the complementary angle. So when you have a right triangle, remember complementary angles are angles that add up to 90. Since you already got 90 degrees taken up by this C, that means the other two angles have to add up to 90 degrees to make 180 for the whole triangle. So A and B in a right triangle, these two angles in a right triangle are automatically complementary. And if A is 10, B is 80. Or if A is 73, B is 17. Now the math way of saying that is whatever A is, B is 90 minus that. And whatever B is, A is 90 minus that. So you could write that as the angle measurement, it guaranteed in any right triangle. Let me show you another thing that you're going to get used to when someone draws a right triangle. People are commonly naming the angles with capital letters. And they also commonly label the side links with lowercase letters. And most people match the letter capital A and the side lowercase a. Capital B, lowercase b, capital C, lowercase c. Although it's kind of awkward to read what's the difference between a capital C and lowercase c. It's not easy to draw. So if you have a question, is that a capital C or lowercase c? I don't mind you asking. Now that means, let's check this out, and let's think opposite over hypotenuse, adjacent over hypotenuse. What is the sine of A? Opposite over hypotenuse, A over C. But if I asked you for the cosine of B, you'd also say A over C, because the cosine of B is the adjacent side to B divided by the hypotenuse. So that means in any right triangle, the cosine of A and the sine of B are always equal to each other. Cosine of A and sine of B are equal. Sine of A and cosine of B are equal. Tangent of A and cotangent of B are always equal. The tangent of A is the opposite side over the adjacent side. But the cotangent of B is the adjacent side over the opposite side. They're both A over B. So you could say cotangent of B, and B is 90 minus A. You could say tangent of A is cotangent of 90 minus A. Cosine of A is sine of 90 minus A. And sine of A is cosine of 90 minus A. Sorry for the scribbling. You could also say the cosine of B is the sine of 90 minus B. The sine of B is the cosine of 90 minus B. And the cotangent of B is the tangent of 90 minus B. This green column here and here, and this black column here and here, these matching things are called, excuse me, the cofunction identities. and they're listed on your formula sheet. Cofunction identities, because tangent of A is the cotangent of B, or tangent of A is the cotangent of 90 minus A. You can always replace one of these black things with one of these black things. You can always replace one of these green formulas with one of these green formulas if you wanted to. Okay, we're focusing now on right triangles. And let's do an example and then maybe just take a break so you can process everything we just said. I sometimes give you guys the short end of the deal. In a 2-hour class, face-to-face or online, I always take a break at the top of the hour. And then here's a 90-minute class and I don't take a break. I think I should give you a break once in a while. Okay, let us remember this situation right here for the right triangle trigonometry. And now let me give you an example. I'm on page 4. I number the pages when I scan them. Let's say you had a right triangle and I told you that this angle was 13 degrees. Now I did not draw that to be 13 degrees. 13 degrees is smaller than this, but let's just say I'm just making a rough sketch. And let's say that this is a waterfall and you know that it's a 1/4 mile away from you. And that means 1/4 mile waterfall. 1/4 mile, 5,280 feet is 1 mile. Cut it in half, 2640. Cut it in half, 1320. That means you are 1,320 feet from the base of the waterfall. How tall is that waterfall? The side that you could call Y, the side that you could call the opposite side. See, if you can measure that angle and you can measure that distance, you can know the length of this side. You can know the length of this side. And it's from the right triangle trigonometry. Here's how to do it. The tangent of 13 degrees is, and I'll slide my paper up in a second after I use this, opposite over adjacent. So if the opposite side is called Y and the adjacent side is called 1320, now, I could name this Y, I could name it H, I could name it any letter I like. So get used to people using different letters. Do you see how you could solve for Y? And this is the point of section 2.2 and 2.3. You'll solve for Y by multiplying both sides by 1320. Now 13 degrees is not one of the famous triangles I gave you, right? I'm going to move this paper out of the way until we need it again. So what am I going to say? Well, I can ask the calculator what the tangent of 13 degrees is. So I'm coming over here. I should have drew the right triangle on this side. So I think you can see my calculator now. I'll say 1320 times tangent of 13 degrees. So famous triangles, 15, 75, 90, 45, 45, 90, 30, 60, 90. You've memorized those sides. And if you're saying with your microphone muted, oops, or no, I didn't memorize those sides. I've got a piece of paper that has them written on it. Memorize them anyway, because you'll be a lot faster and a lot more accurate. Anyway, 13 degrees, I have no triangle memorized like that, but the calculator, and notice I'm in degree mode. I hit the mode button down here. Calculator says I'm in degree mode. I can ask the calculator for the tangent of 13 degrees and multiply it by 1320. The tangent of 13 degrees is some crazy number. I don't want to write it down. I just want to know what 1320 times tangent of 13 is. It's also a crazy number. 304.7460123. And so here I'm going to go with this. 304.7460123 feet. Now, if I circled that and put it on a paper, or if I was a surveyor, or if I was, park ranger, and I wanted to know how tall that waterfall is, do you know what they would do to me? They would fire me right there. How far is it to Myers, Dave? Oh, it's about 5.172965423 miles. You would look at me as if I was crazy. How far is it to Myers, Dave? Oh, it's about 5 miles. What does it mean to give somebody all these digits right here? When someone gives you an answer filled up with numbers and digits, it's almost like you're promising them, or they're promising you, if they gave that to you, that they did super precise measurement. And they know this answer so exactly that you should be impressed. Of course, you're not impressed because they just wrote it off the calculator. But it raises this question, doesn't it? How many digits should I use? Let's take a look at the problem. I'll move the calculator. I measured the distance between myself and the base of the waterfall at 1,320 feet, quarter of a mile. Did I do that with surveying equipment? Did I do that with a rangefinder? You can get yourself a fancy rangefinder for golf, for archery, for hunting, competitive shooting. Did I measure this to the nearest foot? Then I gave you 4 digits of accuracy. Now, I probably, when I just casually said a quarter of a mile, if someone says to you, oh, you just go a quarter of a mile down the road, I don't think they measured that you should go 1,320 feet down the road. They're just speaking casually. But let's look at this expression right here. Someone gave you 4 digits. To be honest, maybe you're not sure about the 0. Maybe they just measured to the nearest 10 feet. You see 3 non-zero digits. You call that 3 significant digits. But over here, you measured the angle. How did you measure that? There's surveying equipment for measuring angles. Maybe you just measured it with a compass. But whoever measured this, they wrote the angle as 13 degrees. And what they're saying is we measured to the nearest degree. So there it's clear that you're given 2 significant digits, or 2 good digits, 2 accurate digits. So now comes time for me to tell you the answer. Can I promise you that the answer is this accurate? No, not really. Not unless I was super precise in these digits. Did I want to measure 13 degrees to the nearest thousandth? Then I ought to tell you I measured 13 degrees to the nearest thousandth. But I didn't say that. I've got 2 digits of accuracy here, 3 digits of accuracy here. There's a basic rule of thumb, and that you use as many digits as you have in the least accurate number. Now, I know the chemistry class professor would give you a much longer speech, and maybe we will too later. But in this answer, I really cannot believe in more than 2 significant digits. I really cannot promise someone that I'm giving them 10 digits that are correct. So if I was to do this problem and write it on a piece of paper, my final answer would be 300 feet. Now the problem is that one significant digit, two significant digits, or three significant digits? If I measure to the nearest foot, it's three significant digits. If I only measure to the nearest 10 feet, to the nearest basketball hoop, then it's only two significant digits. If someone doesn't tell me, you count the non-zero digits until you reach the last non-zero digit. Here's only one significant digit. Did I measure that waterfall only to the nearest 100th feet? Could be 300, could be 340, could be 260. No, I did better than that. So if I want to tell someone I use two significant digits here, I could just tell them in plain English that I did this to the nearest 10 feet. Sometimes people in science classes write this in a fancier way, 300, and that means that that digit is accurate, that it is 300 feet to the nearest 10 feet. Might be 304, might be 301, might be 298, but it's not 337. You are within 10 feet of the truth. So this game that we're playing right here, you can do the calculations with a calculator all day, but don't write down a crazy answer like this when you're done. Write down the correct answer with significant digits. Also, when you're working, never round off till you're completely done with the problem. And I'll give you an example of that when we come back from the break. Never round off till you're completely done. I want to show you a problem like your second written homework. But once you are done and someone asks you for the answer, always choose an appropriate number of significant digits. Okay, this game where someone gives you some pieces of the triangle and asks you to find the other pieces, that's called solving a right triangle, where they give you some sides and they ask you to fill in all the other sides. Now, let's just hang out for a second. I'll give you a chance to stretch your legs. I should do that more often. I've got 128. So let's come back in 5 minutes. I'll try something fancier with more angles in it. And we'll practice again using the trig functions to solve the triangle. That's why people invented trig functions. And using the right number of significant digits. Okay, stretch your legs for a second. I'm just going to mute the microphone. If you have questions still you want to throw in the chat window, go right ahead, or you can spit them up when we come back. Okay, let me come back here. I want to pick out a particular problem. And it's a little bit like the homework problem you're going to do this week, written. This is in section 2.3. And I'm looking at 45 and 47 through 50. The problem you're doing in your written homework looks more like 45. But what if we tried this one right here? Let's look at this problem. And I won't take this one exactly, so you can go and practice this one, but I'll draw something like this. Let's say that this height h right here is a tree. And that tree is probably pretty far away from you. Or a building. Let's say it's a very tall building, some building. And you don't know how far you are away from that building. Total distance. But you can use your instruments and take a reading to the top of that building of a certain number of degrees. Then you could take a distance, like you walk 100 feet over or 150 feet over, and you take another reading with another angle. Can you then tell how tall the building is? Well, let's try it out. So I'll draw a picture here. Like the book, and I'm going to use different numbers, but it'll be a picture like the book. So I'm very far away from a tall building. And I don't know what this distance is, but I assume the building's at the right angle. It's not a Leaning Tower of Pisa. But let's say I have a surveying instrument or just an ordinary compass or protractor, and I can measure this angle to be, I really don't know. I'm just going to pick numbers out of the air. Let's try them out. 23 degrees. And then let's say I can walk 151 feet. That's not a long distance. Let's say I measured that very carefully to the nearest foot, 151 feet. And then I measured this angle. I don't know what to call this angle. Let's call it 38 degrees. I'm just picking reasonable numbers. I'm not saying that this is exactly 23 or exactly 38. I'm just saying, let's eyeball it. So with that information, here's an interesting challenge. Could I know how tall that building is? Let's try it out. And you could be suspicious. You could say, no, you got to tell me how far you are from the building, or you got to tell me how long it is along this line of sight. You got to give me some other sides or I can't work. Because you're used to saying what? If I know two sides, I can find the third side. If I told you the length of this side right here, you could use the Pythagorean theorem to find this length, then you could add them up. You know, something like that, right? But let's just use the relationships in the triangles. Let's admit to the things we don't know and then see if we can find h. Like here's one thing I don't know. I don't know what this distance is. Even when I finish walking forward, I don't know how far I am to the building. And my drawing is not a scale drawing. As I drew it, does it look like 200 feet? Does it look like 210 feet? I really don't know. Let's just call that X. How tall is the building? They don't know. That's what I'm trying to find out, right? But I do know this, that the tangent of 38 degrees is opposite over adjacent. And my calculator will tell me the tangent of 38 degrees. The problem that I'm doing right here is actually a little bit harder than your written homework problem. So you could do the written homework problem maybe without doing as much work as we're about to do. But what else do I know? I know that the tangent of 23 degrees is h over this long distance. What is this long distance? I don't know it exactly, but it's x plus 151, whatever x is. So I could also say the tangent of 23 degrees is h over adjacent, opposite over adjacent, h over x plus 151. Now let's consider those two things, because if I multiply both sides by x in the first equation, it says h is x times tan 38. Now, when you're doing a problem like this, don't be in a hurry to ask your calculator what the tangent of 38 is. When the time comes, the calculator knows. But I don't want to write down tens and tens of digits. I don't want to write down lots of digits, copy, make mistakes, round off badly. Let's let the secret here stay with the calculator. But I can also say h is what by the second formula? Multiplied by x plus 151. And that's the tangent of 23 degrees. Now, do you know how I'm going to find h? I could set these two things equal to each other. Both of these things equal h. And if I set them equal to each other, x tan 38 equals x plus 151, parentheses, tangent 23. I could find out what x is. And once I know what x is, I can use a tangent relationship to find out what h is. Let's try it. Now I have to distribute on this side. So, and I might run out of room and have to start again on the next paper. But x tan 38 is equal to x times tan 23 plus 151 times tan 23. Okay, and also remember what I just said. This is a mistake people make. Do not go rushing to your calculator to find that number. When you need it, you will ask. Let's just keep it laying around like this. How do I solve for x? I have to bring all the x's to one side. I'm doing a little bit of algebra right now. And I have two pieces that both have an x in them. So I am allowed to factor out the x and write tan 38 minus tan 23 equals 151 tan 23. Now there's two ways to look at this, and I will have to go to the next sheet of paper. You could look at this as a horrible mess, or you could look at this as x times a number equals a number. I will find out what x is in 1 second. I just divide by this number. And then I know what x is. Well, let me show you a slick way to use your calculator. So I'm going to take this to the top of the next page. labeling my pages as I go. So I'm going to just rewrite this so I can move the other page off my screen. This is a very useful calculator trick that I'm about to show you. And it's a very useful solving trick. People sometimes get in a lot of trouble because they fill in these intermediate numbers. They ask the calculator what these numbers are. They round off, they subtract, they do something oddly, and then they get off in their answer. Don't evaluate these numbers, let the calculator evaluate them. So X apparently is 151 tan 23 over tan 38 minus tan 23. And now that I have my X, now I will type all this into the calculator, very carefully, of course. Let's see if I can slide that over. Need a little more calculator room. Let me type that in right here with lots of parentheses so that I keep everything straight, right? Sometimes I use more parentheses than I need, but there's no harm in that as long as they're balanced. 151 tan 23, stop the tangent, stop the numerator. So those are the parentheses for the top, divided by, now parentheses, tan 38 minus tan 23. Tan 38, stop the tangent, minus tan 23, stop the tangent, and then stop the denominator. Now, all kinds of calculators are different. So this calculator runs things off the screen. Sometimes calculators print things down the screen. Sometimes calculators use tinier letters. When I get done typing, the calculator will show me what I typed, and then I can check that I typed it correctly. Well, let's ask the calculator what this number is. Calculator says 179,634,9645, all the digits. Calculator just gives you everything it's got. And this arrow over here says I could arrow over and see what I typed. I'm not going to do that right now. So even though I'm going to write this down, 179,634. See, I never know when to stop, right? 635, 6349, but then I have to round up to 50. The problem is I don't know how far to go. But how many significant digits should I use? Let's go back to the building. I have 3 accurate digits right here, 151, 3 significant digits, but in the angles, I only have 2 significant digits. You know, if they had measured 38.0 or 23.1, then I would have 3 significant digits there too. I guess I can't promise anyone anything more than 2 digits. So let's go back to what I calculated. If someone told me to round that off to 2 digits, I would say 180 feet. But remember, this isn't the answer. This isn't what they wanted. So let me show you how to avoid another critical mistake. This distance is 179 and change, right? 180 feet roughly. But they want to know how high this building is. Now I could take that number that I just found right here. Didn't I just tell you that X is 180? Well, the problem is I told you that X is about 180. And I want to know H as good as I can. So I want to put in every single digit the calculator gave me for X and then multiply it by tan 38. Let me show you how to do that. So I'm going to write down here, but I want H. the height of the building. And what we said earlier was H was X times tan 38. I do not want to just round off and stick the 180 in there. My answer will not be accurate. On the other hand, I don't want to type all these digits in there because that's a pain in the neck. That's why I bought the calculator. The digits are right there. I could do two things right now. I could hit the multiplication button and the calculator would automatically take that number with all the digits and the 3 more off the side and multiply by tan 38. I could also, here's another really interesting feature, and it's way down here in tiny print. Do you see right here on the minus key, it says ANS, answer, blue ANS. What I could do is type this blue modifier key and then ANS, second function ANS. And what happens when you do that is the calculator retrieves the last answer that it gave you and puts it right there. It doesn't type it, but it takes that number and puts it right there. Now I will multiply by tan 38. And what am I feeling? I'm feeling very good because I used every single digit I could. I won't write the answer with every single digit. Tell me what you mean by entire. I like the question because I want to make sure, but, oh, sorry. Can you show the whole entry? I want to, no problem. Now I'm going to ask you again. Is this the whole entry, or do you want me to show this part up here on the top line? Very good. Okay, and that's why I want to ask a question, because there's another trick to see that. Do you see down here on the enter key, it says in blue, entry? And the calculator, if you type entry with a blue key, the calculator will give you a list of the last things you did, and that would include this line up here. So before I do that, let me write down the answer that the calculator just gave me. 140 3462158. But that would be crazy if I told someone that's how tall the building is. How tall is that building? I cannot promise anything more than 2 digits because my angles were not measured to more than 2 digits. I'll show you that because, yeah, that's probably what happened. So let me show you that just a second. So what I can say to people is that building is about 140 feet tall. Could be 141, could be 140 and a half, could be 139. But I am very confident that it's to the nearest 10 feet, 140 feet. Okay, now watch what happens when I do second function entry. I don't think I can get my whole calculator on the screen. Let me try it. Second function entry, here's the entry key down here on my right forefinger. There's a second key on my left forefinger. The second function entry, that's the last thing I did. But if you keep going second function entry, it'll tell you the next to last thing you did. There's the next to last thing I did. And you might have a negative number here if you got this denominator backwards. So did you do 151 tan 23? When you divided, did you write tan 23 minus tan 38 or tan 38 minus tan 23? That's where you might be getting a negative sign. Now you don't see that in what I typed, right? So now it's time I can arrow over to see exactly what I typed. I typed, unfortunately, it kind of flies off the screen badly, tan 38 minus tan 23. I can arrow back and forth. What did I put on top of this fraction? 151, 10, 23. Now, one more time, could you get in a negative number for another reason? Yes. Are you sure that you're in degree mode? So press your mode button, make sure you're in degree mode. If you're in radian mode, I don't even know what would happen. We haven't done radians yet, but I could ask the calculator what would happen in radian mode, negative 187. Are you getting the negative 187 exactly? Good. Okay, so right now, make sure we're in degree mode. Got it. Thank you for asking that, because I can show you lots of cool things on your calculator. And frankly, I do not know all the cool things calculator does. I mean, it does a lot more than I know. On the other hand, I can show you some wicked time savers, like the answer, second function answer, and second function entry. Okay, but now how do you feel about this building? And we're gonna wrap it up here. You know what I told you? I told you the building's 140 feet tall. Are you gonna yell at me because you wanna know to the nearest inch? Or you wanna know to the nearest millionth of an inch? No, you're probably pretty happy. I walked 151 feet, I measured. That building is more or less 140 feet tall. And I promised you that's the answer to the nearest 10th feet. So is it 146? No, that would be 150. Is it 134? No. You've got a fair feeling for the height of that building. If you want a better feeling, if you want more accuracy, in fact, if you wanted 3 digits, if you wanted to know that building to the nearest foot, you could have, but then you would have had to give me these angles a little bit better. And that's the real story about significant digits. Significant digits are just a way of saying, don't overpromise, don't over-deliver accuracy, don't under-deliver accuracy. Just tell people what is reasonably honest for that number by the number of digits using. We're going to do more practice with that later. Okay, I'm going to scan these, post them. I'm going to stop recording and post the recording. I'm going to read through the problems you handed in last night so I can get them back to you. And then I'll show you how I get them back to you over the end of this week, so that by Monday you got them back to you and you know kind of what your grade is, kind of how I'm going to return papers to you. And you know the kind of things that I'll write on your papers. So you guys are Monday, Wednesday, so I don't seriously believe you're off to the weekend now, but at least you don't have to come back here today. Remember though, you get in that system every day. Okay, you guys have a nice weekend. I'll see you later.